Welcome to the Elon Musk Signal Channel. The International Space Station, ISS, humanity's largest artificial structure, is scheduled to conclude its mission by 2030. Preparations for this momentous event are underway, notably the $843 million contract awarded by NASA to SpaceX to develop a new orbital departure vehicle named USDV. Surprisingly, USDV is predicted to be an upgraded version of the familiar Dragon spacecraft. How will Dragon be enhanced to support the process of deorbiting the ISS? Let's explore right now. The US, along with 4 international partner agencies representing Russia, Europe, Canada, and Japan, has been preparing for the eventual end of the ISS, which has been crewed since 2000. The ISS, primarily created as a crewed research laboratory, has seen more than 3,300 experiments conducted in microgravity. That includes research not possible on Earth, such as medical sciences and technology demonstrations. The ISS is aging. Bringing the ISS out of orbit is a major project requiring meticulous preparation, especially in the selection of organizations and vehicles for execution. It appears NASA made the right decision by partnering with SpaceX. The vehicle crafted by SpaceX will efficiently decommission the ISS by propelling the station back into orbit. According to NASA, this will either be a new spacecraft design or a variant of an existing one. This vehicle must perform flawlessly on its maiden flight and be equipped with comprehensive backup systems and contingency recovery capabilities to successfully complete the critical deorbiting mission. NASA is considering 2 main options for USDV. First option is designing a new spacecraft. This choice presents several advantages. A new design can be fully optimized for the ISS deorbiting mission, ensuring maximum performance and reliability. It can also incorporate cutting-edge technologies not previously applied, enhancing operational capability and mission safety. However, developing an entirely new vehicle demands significant time, resources, and higher costs. Additionally, testing and proving the new spacecraft's capabilities will also be costly and time-consuming. NASA needs to carefully weigh these factors before making a final decision. The $843 million contract for this project is significantly lower compared to the contracts awarded to SpaceX and Boeing in 2014. Furthermore, NASA emphasizes that the vehicle must operate effectively on its first flight and be equipped with full backup systems and contingency recovery capabilities to successfully complete the critical deorbiting mission, which also requires a considerable amount of time. Naturally, SpaceX would not want to waste time when they can utilize their existing excellent resources. Therefore, let's focus on the second option, upgrading an existing spacecraft. SpaceX's Dragon spacecraft is certainly the most suitable choice. Dragon has maintained ISS operations with high reliability. So how will Dragon be upgraded to complete the deorbiting mission? The official version has not yet been disclosed by SpaceX. However, upgrading the Dragon spacecraft to carry out the ISS deorbiting mission is a topic of great interest and has led to various speculations and predictions. Speaking of improvements to Dragon, we can also consider a previously mentioned variant, Dragon XL. The XL version is designed for lunar missions, larger than the original Dragon, with a mass ranging from 15 to 16 tons. Of course, this mass implies that Dragon XL will be launched by Falcon Heavy. This version still uses Draco and Super Draco engines, but is configured for lunar missions. It is known that XL can carry over 5 tons of cargo to the Lunar Gateway, meaning it can carry more mass for ISS missions in low Earth orbit. Therefore, Dragon XL is also a version that SpaceX could consider if they decide to deorbit the ISS. NASA and experts once proposed pushing the ISS into lunar orbit for reuse or outpost construction. However, this method is impractical, consuming vast energy and incurring high operational costs, while the ISS equipment is outdated for long-term strategies. Therefore, sending the ISS back for oceanic descent, assembly, refurbishment, and reuse is the optimal solution. This process will rely on Dragon's support, including methods like disassembly and fragmenting the ISS in space, pushing it to higher altitudes, converting it to commercial use, or leaving it in orbit beyond 2030. Looking at the aerospace industry, currently no other vehicle matches Dragon's capability. Starliner has only succeeded in 1 cargo mission and remains stuck on the ISS with its first crewed mission pending. Dream Chaser has yet to launch and may take significant time to handle a challenging task like deorbiting the ISS. Orion faces numerous issues and is extremely costly, developed solely for lunar missions. Only SpaceX, with proven reliability, remains NASA's best choice at present. 2030 approaches, and Dragon will maintain its dominant position both before and after this milestone in the space race. To date, SpaceX has successfully completed 13 crew missions, including a demonstration mission, 8 commercial crew program missions for NASA, 4 private missions, and 30 cargo missions. This achievement sets a high standard that other vehicles will struggle to match in the years ahead. However, SpaceX shows no signs of slowing down and is prepared to further expand its record. Future plans include up to 6 commercial crew program crew missions for NASA, additional cargo missions, and private crew missions. The future of this spacecraft promises great potential. Whether for government or private missions, cargo or crew, all paths lead to the ISS. In the remaining 6 years of ISS operational life, Dragon will undoubtedly play a central role in its bustling activities. Meanwhile, Starliner faces significant challenges, as the CFT mission remains unfinished, making it one of this year's major disappointments in the aerospace industry. While Dragon easily achieves its goals, Starliner struggles post-CFT-1. Starliner 1 mission is scheduled for early 2025, though uncertainties persist due to current issues. Even upon launch, it will lag far behind Dragon's Crew 10. All this underscores a significant gap. In addition to supplying materials to the ISS, Dragon will play a crucial role in constructing and supplying materials to new commercial space stations. Alongside Blue Origin's orbital reef, other notable projects like Starlab, Axiom Space Station, and the Expansive Space Station are all linked to SpaceX. Dragon is proving its worth as the chosen vehicle for the ISS deorbiting mission. Though this mission is years away, it's an important time to appreciate the ISS and anticipate Dragon's future achievement. With its reliability and capabilities, SpaceX's Dragon is ready to ensure a spectacular end to the ISS's mission. This conclusion will mark the beginning of a new era where advanced platforms will propel humanity deeper into space. SpaceX's Dragon will certainly continue to be at the center of this exciting future. And those are the notable insights from today's broadcast. Leave your comments on this episode and stay tuned for more anticipated events in the upcoming episode. Thank you for watching. Don't forget to subscribe to the channel and turn on notifications to catch more interesting videos on the Elon Musk Signal channel. Goodbye, and see you again.